my name is Jordan Depew. This is Jared Skivoski. We have the idea of an integrated neural sensor. Now, when people have amputations either from motorcycle accidents or from some sort of injury from a war, from an IED, the brain kind of rewrites how the sensory organs are set, or how it senses with the peripheral nervous system. So it sends nerves that would normally be on the limb that was there, and it sends it to another part of the brain, or to another part of the nervous system. But it still sends signals down to the amputated limb, and they still feel constant pain on occasion. So, by simply...
Okay, so basically our objective here is to create a type of like sensor that you would physically like attach to the neurons in the nerve, and then through the use of this you could make a signal send between the brain and the nerve connecting and try to lessen the pain, or just send something back to at least, make them feel a little better.
Now we go about by doing this by testing on small rodents, either rats or mice, because of the fact that the peripheral nervous system is very similar to ours. And we would first test by sending small electrical signals to see if the brain would actually react to it, and finding a low enough voltage to where it wouldn't completely fry the nervous system. And by doing so, we would also want to develop a system that would be safe enough to be protected from various other electrical signals, either by radio waves or stuff like that. Now, this is quite relevant to biology because we're directly dealing with the nervous system, but it's also quite dangerous in the fact that we could potentially fry someone's nervous system, just pretty much paralyze them from all over their entire body. But if we actually do this, we're helping a lot of people. And there's a lot of other applications that we could further go forward with this. Like we could develop full-blown automatic or prosthetics that would just directly react with someone's electrical impulses from that brain.
It doesn't even have to be just a limb or anything. It could be like an eye eventually. Because if you connect that to the nervous system with a camera, you could actually have that work as a new eye.
Now, there are various corporations that currently make prosthetics, the most common of which is Endolite, which they have the most advanced prosthetics to date, where they pretty much function at a much higher level in terms of mechanics, but they're not automated yet. With introduction of technology like this, they could become automated. Now, Touch Bionics, they're mainly working with amputees from the forearm, and it's an app that goes through and you can touch the different types of formations like a closed fist or a finger pointed out, and by using this app, and they can use it to actually grab things. Now, if we apply this to it, you can directly attach to the nerves, and you just eliminate the app entirely and just directly interact with it. And veterans are kind of our main goal of helping out here, because we have thousands upon thousands of veterans every year coming back from war with injuries that, besides the fact they have PTSD, they also have, in most cases, amputations or limitations like this. And by providing this can help them. This can help with their pain. And these are resources.
Okay. Questions, please?
Yes.
Who are you guys?
40.
Okay, so you're making the sensor, and you are attaching the sensor to the nerve ending of
Yes.
the real actual nerve ending,
Yes.
not the one of the prosthetic.
No.
So you have a nerve ending of already amputated
Yes.
somebody, right?
Yes.
And you put that there so that it will regulate the signals of the nerve endings, or it's the one sending signal? That's
With
the
the
part I
peripheral nervous system, it sends a signal out to the limb, pretty much asking, is there a limb here, is there pain?
Right.
And we would pretty much measure how much of voltage it takes whenever that signal is sent, and then it would bounce back an all clear signal back to the brain, letting you know there's a limb there and there's no pain. And that would bring down the phantom limb pain that they usually have amputees feel.
Now, some of the other systems I've seen for like bionics, where they have a remote control, where they go catch the signal somewhere up the brain and it's fine, and they'll use that to control, limb. Do you know if the patients who use that system still have phantom limb pain?
As far as I know, they still do.
Okay.
Because it's not directly attaching to the nerve ending that's actually causing the problem in the first place.
So what would be your baseline of how much electrical impulse should be
Very low.
sent to, or do you have any, at least some reference that have already kind of determined this, that, you know, in sending pain, this is the electrical impulse, or this is, you know, have there been any study on that?
Not that I could find out.
Okay.
So that's something I intend to put more research into and find.
Right, and also, like, you know, how people eliminate the pain chemically because, of, for example, if you take, you know, drugs, there's a mimic on the drug, on the nerve ending. And so, you know, if maybe you can get some data on that where, because it's really after the nerves has that drug in there, it's the electrical signal that's being transmitted still by the nerve. So I know that if you take those drugs, right, it masks the pain.
But it's temporary.
Right, but what I'm saying is that your baseline on electrical impulse signal can probably be based on that. So if there's a study that, you know, and you know how this is, your meth, for example. You take meth and you're high and you don't anymore feel anything, any pain or whatnot, right? And it's because of that electrical signaling. So if you can get an article that actually looks at the electrical signal, not the chemical, right? Because usually what they study is the meth itself, right? That how it masks there chemically binding with the neuron. But if there is a study that actually looks at the electrical signal, that could be your baseline, right? In the process.
I have a question. Like, so your device is trying to stop the pain from any nerves and the brain, right?
Yeah.
So basically, like, how do you distinguish? Because I mean, pain is a signal trying to send to your brain, like tell your brain like something is wrong. So how to distinguish between these two? Like, it's just a pain or tell something is wrong.
From that, you could assume that there is going to be slightly different variances in the voltage that's being sent through the system, because it wouldn't make much sense for the brain to simply just send one straight voltage to the system. So you have to assume that the brain is sending slightly different voltages to assume that that's pain, or you're touching something, or you're seeing something.
That's an assumption, but that's a good question though. Because now you're trying to fool your brain that, right? Okay, whenever this electrical signal is sent to you, it should not be painful. So if you have actually a actual pain now, then your brain is confused. Oh, there's actually nothing wrong there, right? So yeah, that actually is a good point to consider, right? And how are you going to be able that the brain still would recognize those impulses differently? Very good. Any other questions? None? All right. Thank you, guys.